Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Well, dear students, let's solve some examples. The first example, if 4x plus I into 3x minus y is equal to 3 plus I into minus 6. It's a straightforward question. What is x and y? It's very simple. See, this is the first complex number, okay, real part and the imaginary part, and this is the second complex number, real and imaginary part. When do you say two complex numbers are equal? If their real parts are equal and their imaginary parts are also equal. So from this given expression, what we understand is 4x must be equal to 3 and 3x minus y must be equal to minus 6, as simple as that. So that's very simple. So x is equal to 3 by 4. Now substitute that in place of x, so which is 3 by 4 minus y is equal to minus 6. So you can just shift that y and 6, see this minus y becomes plus y, minus 6 becomes plus 6. This is the quantity you have to analyze now. So you can take LCM 4, right? So this is 9 plus 24 divided by 4. So which means this is 33 divided by 4. So 33 divided by 4 and 3 by 4. So this is the option, right? So 33 by 4. So B is the right choice for this question. Well, let's move to the second problem. Second problem looks little different, but it's based on algebra of complex numbers. Alright, the second problem is based on algebra of complex numbers. You have cube root. It's difficult to find cube root, whereas it's easy to find cube, right? So we'll just cube both sides. So if you cube both sides, see what we are doing, cubing both sides. Then what will happen on the LHS? So that will be x plus iy, and here this will be a plus ib whole cube. Yeah, now use a plus b whole cube formula. So that is a cube plus 3a square b. So in place of b you have ib, yes, and then 3a and b square, that means here ib square, and then ib cube. So that's the formula to find a plus b whole cube, and we have applied that formula here. Next, say this is a cube and 3a square ib plus, see I square will be minus 1. I'll just replace it straight away, 3a, and this is b square. I square I have written minus 1 already, and here you will get I cube. I cube is minus I. So this is minus I and b cube. Now what I'll do is I'll take real parts and imaginary parts separately. So here a cube and minus 3ab square, and I'll take my I common. Okay, so this is 3a square b, 3a square b, and minus b cube. I have taken I common. Alright, so here LHS is x plus iy. Now again, two complex numbers are equal. What does that mean? So if two complex numbers are equal, the real parts are equal. So from this I will get x is equal to a cube minus 3ab square, and then y is equal to 3a square b minus b cube. Then what we need to find is this expression x by a minus y by b. So first x by a, y by b. Yes, so what is the x here? So that is a cube minus 3ab square divided by a minus 3a square b minus b cube and divided by b. So this is the quantity we have to analyze now. So let's go with that. Look at this, you can take a common, so this will be a square minus 3b square and divided by a, which will eventually cancel, and here I'll take b common, so 3a square minus b square divided by b, once again b will cancel and you're left with a square minus 3b square and multiply this minus, so that is minus 3a square and plus b square. Well, so a square minus 3a square is minus 2a square and minus 3b square plus b square is again minus 2b square. We can take minus 2 common, hence it is a square minus b square. So which option is the right choice for us? Is it A? No, it's the option B and it's not C or D. So option B is the right answer and we have proved it with this algebra of complex numbers. It is just a plus b whole cube formula that we need to apply. Now x plus iy, third question, into 2 minus 3i is equal to 4 plus i. What we need to find? X and y. Okay, so let's find x plus iy. From there we'll get real part and imaginary part. Let's see. So third question, you have got x plus iy into 2 minus 3i and that's equal to 4 plus I. Now what I'll do with this is I'll just shift it to the other side. So this is 4 plus I and this is divided on the other side because it was multiplied on LHS. So when you take it to the right hand side RHS, it will be divided. Now what we need to do here is rationalize. So multiply and divide by the conjugate of the denominator. So 2 plus 3i divided by 2 plus 3i. Hence you have got to multiply now. So multiply carefully. Okay, so 4 into 2 and 4 into 3i and then 2i and then I into I is I square divided by, so this is a minus b into a plus b, therefore a square minus b square. Let's simplify this I square now and then we can add these. So I square is minus 1, okay, I'll write it anyway. So this is 14i and 3 into minus 1 divided by 4 minus 3 square 9 and then I square. So once again in the denominator you see I square, right? So write it as minus 1. Okay, so we'll write it as minus 1. And what we are talking about? X plus iy. Don't forget the LHS. Left hand side is x plus iy and on the right 8 minus 3 plus 14i divided by 4 minus 9 into minus 1. So 8 minus 3 is 5 plus 14i and divided by 4 plus 9. Okay, so what is 4 plus 9? 13. Yes. So you have 13 in the denominators, so one of them, let's see. So this is 5 plus 14i divided by 13. Now you can split. So 5 by 13 and I into 14 by 13, right? Okay, so you're just splitting the numerator, take the denominator here and there separately. So now this is x plus iy, hence what is the value of x? 5 by 13, hence the value of y is 14 by 13 it is. Therefore option C is the right answer for this question. We are in the fourth example, and this is regarding the basic idea of complex numbers. So here Z1 is one complex number which is given as 2 plus 3i, and Z2 is the second complex number given as 1 plus 2i. Then we are asked to find Z1 by Z2. Well, so the options are as follows. It's a very simple question on division of two complex numbers. So let's just substitute Z1 and Z2 in their respective places. So Z1 by Z2 is equal to, you have got 2 plus 3i divided by 1 plus 2i. Now, how do you divide two complex number? You just have to multiply and divide by the conjugate of the denominator. Right? So multiply and divide by 1 minus 2i, and hence continue. Multiply them. All right. Usual multiplication. So 2 into 1, and then 2 into minus 2i minus 4i, and then 3i, and finally minus 6i square. Next, this is a plus b into a minus b, which can be written as a square minus b square, which is like 1 square minus 2i the whole square. Let me continue here. So simplified, we have got 2, and minus 4i plus 3i is minus i. Now you substitute the value of I square, which is minus 1. So that would give you 6 into minus 1, which is plus 6. We will replace it later. Now this is 1 minus 4 because 2 square, and then I square. Next we will have to write this plus 6 and minus I, and this is 1 minus 4 into minus 1, which is like 8, and then minus I obviously, and 1 plus 4, which is 5. So we can write 8 by 5 minus I by 5, which also can be written as 1 by 5 into I. I hope you understood. So that is 8 by 5 minus 1 by 5 I, which is option A. Therefore, the question number 4 has given us the right answer, and that is option A. Let's move to the the fifth problem here. All right, the real part of the complex number. So you got to find only the real part, not the full complex number. See, this is the full complex number a and plus ib, whereas b is minus 1 by 5. Correct. So here, what is the real part in this complex number? 8 by 5. So that's given in the options. Okay. So only the real part is what we have to find in that. So it's not a big thing there. So questions on complex numbers are very simple. All right. So only the thing that you have to remember is I square is minus 1. Substitute throughout wherever you get I square, and that's it. You have your answer. So let's quickly solve the fifth question. The real part. So let me write this as z. That is 1 plus I square divided by 3 minus I. Now what I'll do, I'll just use the formula a plus b whole square. So that is like 1 square plus I square plus 2ab term. Okay, 2 into 1 into I, that is 2I divided by 3 minus I. Next I square, let me substitute, and then this is 2I itself, and you have got 3I. Next this is 1 and minus 1, which will cancel, and what remains is only 2I divided by 3 minus I. Now this is still z, complex number, right? But this is not in the standard form of a plus ib. So what you have to do here is rationalize. That means multiply and divide by the conjugate of the denominator, and that is 3 plus I. So that's what I am multiplying and dividing by. So multiply the numerator terms there. So you have got 6i and then 2i square divided by, see this is again a minus b into a plus b, which is a square minus b square. That is like 3 square minus I square. So let's continue here. So this is still z. Well, so you have got 6i and plus 2i square. So I square, write it as minus 1 obviously. So 2 into minus 1 is what you have to got right here, and this is 9, and then minus value of I square is minus 1 there. So minus 2 and then 6i divided by 9 and plus 1, which is like minus 2 plus 6i divided by 10, right? So now separate them. So separate them. Minus 2 by 10 plus 6 by 10i, which is like minus 1 by 5 plus this is like 3 by 5i, simplify by 2, correct? So now identify the real parts. The real part is minus 1 by 5 and the imaginary part of this complex number is 3 by 5. So you are asked to find only the real part, and that is minus 1 by 5, and that is none of these. Yes, so none of these is the right choice. So option D is the answer for the 5th question. Well, let's move to the 6th question. This is just finding the square of this term. So let me find 1 minus I divided by 1 plus I. Let's see what it gives us. See, this is so simple. This is so simple if you just work on this. Okay, so you have got 1 minus I divided by 1 plus I. So what you have got to do here is rationalize, multiply and divide by the conjugate of the denominator, which is 1 minus I, right? So this is 1 minus I the whole square, or you can just multiply, doesn't matter, and this is a plus b into a minus b. So that is like a square minus b square. So a minus b whole square formula, 1 square and plus I square minus 2 into a into b. Well, divided by 1 and I square is minus 1. Then I square value here, so which is minus 1 divided by 2i and 1 plus 1. So if I take this as z, okay, so what is that? Minus 2i, because they cancel out, and divided by 2. So once again cancel 2, and that is only minus I. Now we have to find this whole square, right? So what is 1 minus I divided by 1 plus I the whole square? So that is like minus I this whole square. So first you have got minus here and then square. So if you have square, minus into minus will be plus, right? And I square is what remains of this. Then finally replace I square, which is minus 1. So this is minus 1, hence the right choice for us is option B, which is minus 1. Well, so let's move to the 6th problem here. Well, let's move to the 7th problem now. If k, alright, is 4n plus 7, then you have to find I raised to k. Well, so k is 4n plus 7. So the options are there. Let's see. which option is the right option. So 7, you have to find I raised to k, which is like I raised to 4n plus 7. Please recall, you have learnt 4 formulas. Okay, so first is 4n, right? So 4n will give you 1, and then 4n plus 1, which is like I, and then 4n plus 2, that is minus 1. Just think like n is 0, because n is integer here, correct? Okay, so n belongs to z, all right. So for n belongs to z, these are the formulas. So if n is 0, then I square is minus 1. Okay, then if you have 4n plus 3, imagine n is 0, so that gives you I cube. I cube is I into I square is minus 1 into I, which is minus I. So these are the 4 formulas that we have. Let's make use of them. Okay, so what I will write here is, I'll write I raised to 4n into I raised to 7. See, when you have powers added here, you can just separate them, and in the separation you will have multiplication, right? Okay, that's the formula for indices. Okay, so if you have the same basis, then powers will be added. Well, so this is the way we split it. Now if you have I raised to 4n, the answer is 1. So therefore this is 1 into I raised to 7. Now you have got only I raised to 7, which can be written as I raised to 4 into I cube. Now again I raised to 4, that is 4 into 1, that is like 4n itself. n is an integer, so here 1 is the integer, correct? So that's again 1, and then you have I cube. Finally, what is I cube? I cube is, n is 0 here, so you have got only I cube, so that is minus I. Therefore the value of this is minus I, and that's the option C. That's it. Alright, so that's a simple thing. If you want to find I cube, then you can use this. If you don't know the formula, you can write this as I square into I, correct? I square is minus 1, and then I, which is again minus I. Alright, so if you do not know which formula to use, you can follow this method as well. That's it for question number 7. Let's move to the question number 8 of complex numbers. Well, you have to find the value of that expression. So I'll just write that expression here. You have got I raised to 4n and plus 1 minus I raised to 4n minus 1 divided by 2. Well, so now let's split this, because we know the value of I raised to 4n, and even you know I raised to 4n plus 1, right? Which is I. So you can make use of this formula, directly write it as I, and here what you can do is, because you don't have the formula for I raised to 4n minus 1, you have only for plus 1 plus 2 plus 3. Okay, so therefore what you can do is, you can write this as I raised to minus 1. Okay, so when you have the same basis, powers will be added. So 4n plus into minus 1 is 4n minus 1, correct? This is the way we can split it. Now again I raised to 4n, replace it by 1. So this is 1 I raised to minus 1. What is I raised to minus 1? 1 by I divided by 2. Now before you bring that I to the denominator, you have to take the LCM first. So take the LCM. So this is I square, and then minus 1 divided by I, and into, this is 2 by 1, when it goes up 1 by 2, correct? So that's the way we work with the fractions, right? So that's the way we divide two fractions. Okay, so the denominator will be inverted there. Okay, you have to take the reciprocal of the denominator, right? Well, let's continue. So that's equal to I square minus 1 and then minus 1 I into 2, that is 2I. Well, so this is minus 1 is minus 2 divided by 2I. So cancel out 2. So that gives you minus 1 by I. Now that's not the answer, because you can't have the imaginary part in the denominator, correct? You can't have I in the denominator. You always have to have the form a plus ib. Okay, so you should have I in the numerator itself. So what do? Rationalize. What is this? This is 0 plus I into 1. So what is the conjugate of the denominator? Conjugate of the denominator is 0 minus I, correct? So multiply and divide by minus I basically. So multiply and divide by minus I. So that's like I here, and this is minus I square. So minus I square, if you have, then I'll take minus to the numerator, correct? So that is for both, okay, numerator and denominator. Whole fraction becomes negative, correct? So then I square is minus 1. So finally you have got plus 1 in the denominator, and what remains of this is only I. So that's the first option, and question number 8, you have got the first option as the answer. Well, all these problems are based on mostly the division of complex numbers or the powers of I formulas. So let's see the next question, and that is question number 9. We are in the question number 9 here. Yes, so the smallest positive integer n, so n is an integer, and that is smallest possible positive integer, for which 1 plus I to raise to 2n is equal to 1 minus I raised to 2n is, okay. So that means these two quantities must be equal, and when it is equal, what is the smallest positive integer n? So the value of n, and that is smallest possible n, we have to find here. Well, as we go along, you will understand how to find that smallest positive integer. Okay, so first you see 2n and 2n. Okay, so that is same. So we can group them together. We can take it together. That means I'll bring this. Okay, I'll bring this to the left hand side. So that will be divided here, and you will be left with 1, because this is into 1, correct? So this is multiplied here, that will be divided in this side. So 1 plus I divided by 1 minus I to the power 2n is equal to 1 is what I get directly from this. Okay. Next, I'll write this as 1 plus I divided by 1 minus I raised to 2n. Now what I need to find is the value of n, so that this quantity gives me 1. So this is easy for us, correct? So before that, I'll just find this quantity 1 plus I divided by 1 minus I. So what you have to do here, you have to rationalize. That means multiply and divide by the conjugate of the denominator, which is 1 plus I. Okay, so that is like 1 plus I the whole square, 1 I square plus 2I divided by a minus b into a plus b, which is a square minus b square, right? So that's like 1 minus 1, I square is minus 1, and plus 2I divided by 1 and minus of minus 1, which is plus 1. Well, I need the options, therefore let's go with this. Okay, so that's equal to 2I divided by 2, because this is plus 1, so 1 plus 1, right? So finally what I get is I, right? So next, what is 1 plus I divided by 1 minus I to the power 2n is equal to 1. So this expression becomes in this place, the value I have got is I, and this is I raised to 2n. Okay, now this is so simple. Now get the value of n so that this quantity becomes 1. So for which value of n, I raised to 2n becomes 1. See, I square is minus 1, correct? Correct. I square is minus 1. What about I cube minus I? Okay, you won't get I cube because n is an integer, you have to put 1. Next you have to put 2. So if you put 2, you will get I raised to 4. What is I raised to 4? I square the whole square, which is minus 1 the whole square, which is 1. So did you get 1 here? Yes. And for what value of n? For what value of n? 2. So 2 is the smallest positive integer. Okay. So what is the next possible? So first value of n is 1. Next is 2. If you put 2 here, you will get 2 into 2, that is 4. So we will get 1. Next, if you put 4 here, that will be I raised to 8. Correct. So I raised to 8 is also 1. I raised to 8 is also 1. But for 2 we have got 1 first. So the smallest is 2. Okay. Otherwise you get 4 and then you will get other values as well. Fine. So that's about question number 9. Let's move to question number 10. And that also seems like working with powers of I. Let's see how it goes. So are you ready for the next question? Question number 10, here it goes. Alright, so I square, what is the value of I square? Minus 1, correct. And what is I raised to 4? 1, right. And what is I raised to 6? Say I raised to 6 can be written as I square the whole cube. I square is minus 1 and that is minus 1. Correct. And then next is I raised to 8. These are even powers, 2, 4, 6, 8 and so on. Correct. Alright. So this is I raised to 8, which will be I square to the power 4. I square is minus 1. To the power 4 will give you 1, therefore next is 1 and till 2n plus 1 terms. Okay, so totally how many terms are there? 2n plus 1 terms, correct. What is the first term? First term is I square. This is the second term. Understand this very clearly. Okay. Understand this very clearly. First, you have got I square. This is the first term. Okay. Then you have got I raised to 4. That is the second term. And I raised to 6. That is the third term. Okay. Now, if you need, see if you need nth term. Alright, so what is the nth term? See, if you have 3 here, that will be double of it, correct? So the nth term is I raised to 2n. So I raised to 2n is the nth term. Now what is the 2nth term? If you have 2n here, then you should have 2 into 2n, which is 4n, double. So if you have 2, that will be 4. If you have 1, double of it. If you have 3, double. Correct. Okay, so I raised to 4n is 2nth term. Okay, and then what is the next term? See, I raised to 4n is the 2nth term. Now totally how many terms are there? 2n plus 1. So what is 2n plus 1th term? So that is I raised to 2 into 2n plus 1, which is like 4n plus 2. It is not 4n plus 1. Okay, this is I raised to 4n. Next is 4n plus 2. That is 2 times. See, this is 2 times 2n. Correct. That is like I raised to 4n. Next is if you have 2n, that will be double. So if you have 2n plus 1, double of 2n plus 1. So that's what I'll write here. It clears so many doubts. So plus I raised to 4n, that is the previous term, and the last term there are 2n plus 1 terms, and that is like I raised to 2 into 2n plus 1. Well, so let's continue with this. Now understand, see these two terms cancel out, the next two terms will cancel out, correct? So similarly you have got I raised to 4n, I raised to 4n is 1, okay, and the previous term, which terms cancel out? First and second, third and fourth, correct? So this is 2nth term. What is the previous 2n minus 1th term? Okay, so 2nth term and 2n minus 1th term cancel. Understand? Group them together, first and second, third and fourth. Okay, so this is 2n, this is 2n because this is 2 into 1. Okay, and that is 2n minus 1, this is 2n. Okay, this is 2n, and this is 2n minus 1. 2n minus 1 is 2n is 4, 4 minus 1 3. All right, so this is 2n minus 1 actually. So 2n and 2n minus 1, the previous term, will cancel out. Okay, will cancel out because I raised to 4n is 1 and this will be minus 1, right? So minus 1 and then 1, minus 1 and then 1 will cancel out in the same order. What remains finally is I raised to 4n plus 2, that's it. So this is equal to I raised to 4n plus 2. Work with this, get one of those options. So that's what we will do next. Well, are you guys ready? Yes. So this is 4n into I square. I raised to 4n, you know, that is 1, and you are left with I square, which is minus 1. So finally minus 1 is the answer for question number 10, and that's in the option B. Well, so did you guys understand this? Well, so next let's work with question number 11, which looks very similar, but it starts with 1 and ends with I raised to 2n. Okay, so this is the nth term, correct? This is the nth term, this is not the 2nth term, this is the nth term, and that is 2n. Not nth term, n plus 1th term, because this is the second term, this is the third term. Okay, you have got first term as I raised to 0, you have got one term extra. Okay, so there are totally n plus 1 terms. Well, so question number 11 now. Okay, so let me substitute. I square is minus 1, and then I raised to 4 is 1, I raised to 6 is minus 1, correct? I square whole cube, I square is minus 1, minus 1 whole cube is minus 1, correct? And then finally you have got I square to the power n, I square is minus 1. Well, now see these two terms cancel and next two terms cancel. All right, first and second, third and fourth, and see, as I said, this is the first term. See, understand, from here till here how many terms are there? N terms and plus 1. So totally there are n plus 1 terms. Okay, so first and second, third and fourth. So finally when it comes, you have got nth term and the previous n minus 1th term, they will group together and cancel out. Correct? Okay. What remains is minus 1 to the power n. Okay. So even number of terms will cancel each other. So but there are odd number of terms. There are n terms. Okay. We don't know odd or even yet. But understand, you have got n terms. Okay. So if n is even, then that might cancel out. Okay. Otherwise it might remain. So now you have got minus 1 to the power n. Imagine if n is even. Okay. So if n is even, that would be 1. So your answer will be 1. So your answer will be positive. Imagine that is odd. Power is odd. If n is odd, so that will be minus 1. Your answer will be negative. Correct? So now the question is whether n is even or odd. What you know is 2n is even, but you do not know is n is even or not here. How many terms are there? N terms. Okay. So do you have even number of terms, 10, or do you have 11? We don't know. Okay, we don't know. So if you do not know that knowledge, then we cannot decide the answer here. We cannot decide. We must know whether this is even or odd. If you do not know, then you cannot determine this answer. You cannot determine. I hope you understood this. Okay. So even though other terms cancel out, we cannot determine the answer because we don't know whether n is even or odd here. Well, so let's move to the 12th question. This is a well-known rule. Square root of AB is not equal to square root of A into square root of B if both A and B are negative. If one of them is negative, this works. If both are positive, it works. But if both are negative, this does not work. I have explained this in detail. Correct? So if you don't remember, please go back and watch that particular video of complex number chapter. Okay, in the board syllabus. Now this is the situation we have exactly. So both A and B are negative. This is what we are given with. We cannot write this. We cannot write this. That's not equal. Therefore you cannot write this as minus 3 into minus 6, and you can write this as root 18, and that's like 9 into 2, which is 3 root 2. So you cannot say that 3 root 2 is the answer. You cannot. Please understand this. Please understand this. All right. So what is the answer then? What is the answer then? So what you need to do here is you have to take them individually and write this as square root of minus 1 into 3. Now both are not negative. Then you can work this formula. So that is like root 3, and what is square root of minus 1? I. So this is root 3i. Similarly, square root of minus 6 is square root of minus 1 into 6, which can be written in this way because both are not negative now. So that is like root 6i. Now start with this. So what is square root of minus 3 into square root of minus 6? That is root 3i into root 6i. So now you can multiply this. That is root 3 into root 6, and I into I is my I square, which is minus 1. So now this is root A into root B, and both are positive. If both are positive, you can write it as square root of AB. Okay. So this can be written as 3 into 6 very well, and that is minus 1. So minus root 18, which is like 9 into 2, which is like minus 3 root 2, and that's the option B. So most students will make this mistake. It's not option A, it's minus 3 into root 2. Okay, so option B is the answer for question number 12. Well, I hope you guys understood this. Okay, so this is the reason. Well, so let's move to the question number 13 and see how we can solve this question easily. Look at this. This is Z. Well, question number 13. What I'll do is I need Z, right, to find Z raised to 20, Z to the power 20. So I need Z. So what I'll do, I'll just shift this 2 minus I to the other side. So here it is multiplied, it will be divided on the other side. So that is like 3 plus I divided by 2 minus I. Now what are you going to do? Yes, multiply and divide by the conjugate of the denominator, which is, so what do you have to multiply and divide? 2 plus I conjugate of the denominator. So now let's multiply this. So you have got 6 and then 3I and then 2I and then I square. Okay, so this is a minus b into a plus b, which is like a square minus b square. So that is like 6, and this is 5I and minus 1. I square is minus 1, correct? And this is 4 and minus of minus 1. That is 6 and minus 1 is 5 plus 5I divided by 4 plus 1, right? So that is like 5 plus 5I divided by 5. So what is Z? You can take 5 common, so that is 1 plus I divided by 5. So that is 1 plus I. So Z is 1 plus I. Now you got to find 1 plus I to the power 20. You can't keep on multiplying it 20 times, correct? So what I'll do is I'll just find I square, then I'll understand what happens to I raised to 20. Let's see. Okay, if I cannot understand, then I'll go to I raised to 4 next, because you can split 20 as 4 into 5, correct? Here I am trying to split it as 2 into 10. Therefore I am finding Z square. So Z square is 1 plus I the whole square, which is like 1 square I square plus 2ab is 2 into 1 into I, 2I, and that is like 1, and then minus 1 and 2I, which is 2I, because 1 and minus 1 cancel. Well, so Z square is 2I. So what about Z raised to 20? So what is this Z raised to 20? Understand, Z raised to 20 can be written as Z square raised to 10, is it not? Yes. So next I'll substitute this Z square, that is like 2I to raise to 10. So this is 2 raised to 10 and then I raised to 10. So this is like I square to the power 5, I raised to 10 can be written as I square to the power 5. So that is like minus 1 to the power 5. Now look at this. See, you have got minus 1 to the power which is odd now. Okay, so to 5 raised to 5 raised to an odd power. So if you have odd power here, if you multiply minus 1 5 times, you are ending up with minus sign, correct? So you will be end up with minus sign here. So that is minus 2 raised to 10, and that's it. That's the answer, and that's in the option B. So second option is the right choice for us. Well, so that's it for today's class. Thank you very much for watching. Well, so we'll come up with the next topic, that is modulus and conjugate. So in the next class we'll work with the conjugate and the modulus. Well, we'll solve a few questions and then move to the next topic. So once again, thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.